In this example, we are given the following rectangular point, 3, -3, that is x, y, and we are asked to, first of all, graph this point in the xy plane, and secondly, convert it to a polar point and give two examples of the polar point, where theta is between 0 and 360. So first of all, let me plot this, part A. Straightforward enough. Doot, 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 doot. 3 on the x, -3 on the y, and there you go. And I'm going to call this point P, so I can label it. So this is point P as desired. Part A was a breeze. Now part B, convert this to a polar coordinate, well, two polar coordinates actually, which both represent this point, for theta between 0 and 360. Well, what I'm going to use to do this is the fact that r is equal to the square root, plus or minus actually, the square root of x squared plus y squared. In other words, r squared equals x squared plus y squared. And also that theta is equal to tangent inverse of y over x. Why do I need these? Well, because a polar coordinate is r comma theta, so I need to figure out r and theta. So now that I have these right here, I can determine my r. So r is equal to plus or minus the square root of 3 squared plus -3 squared. That is plus or minus the square root of 9 plus 9, which is equal to the plus or minus the square root of 18, or in other words, 2 times 9. And the 9 can simplify to become a 3 square root of 2. Now, as far as the plus or minus, which one's which, well, that depends on what angle we use. So let's pause here as far as the r and go to theta. So my theta is tan inverse of y over x. Well, my y is -3. My x is 3. So this is tan inverse of -1. And now I will think of the unit circle, specifically the quadrants of the unit circle, and I will think, when is tangent negative? Recall that the way the inverse trig functions work is you're asking yourself, this trig function of what gives me the value here? In other words, tangent of what angle is going to give me -1? Well, first of all, tangent of pi over 4 would give me 1. Now, remembering that for the first quadrant, I can figure out where it's positive and negative. So first of all, it's +1 here. Remember, tangent sine over cosine. In the first quadrant, both sine and cosine are positive. In the second quadrant, sine is positive while cosine is negative. And then here, both sine and cosine are negative. And then here, sine is negative while cosine is positive. All students take calculus. All trig functions are positive here. Sine is positive here. Tangent is positive here. And cosine is positive there. Okay, so I want to know, where is tangent negative? Well, as we see here, the only place that tangent is positive other than where they all are is over here in quadrant 3. So that means that quadrants 2 and 4 will contain the thetas we are looking for. So theta is going to be equal to 3 pi over 4 and 1, 2, 3, 4, 5, 6, 7 pi over 4. Cool. But now, which one's which, and which one goes with the plus or the minus r, and how do I know? Well, if I look here on the graph that I originally have, I can see that, let's first of all suppose that r is positive. So I'm going to have the coordinate +3 root 2. And now we go, okay, well, what angle does this need to be? Well, it's an angle that swings all the way around to here. So that's going to have to be 7 pi over 4. That swings me all the way around into the fourth quadrant. All right, so what about the negative r, the -3 root 2? Well, in this case, what we can do is go directly opposite to this. And that's what the negative r will do, is if I'm pointing over here, the negative r will cause it to point in the opposite direction. So we can see here that that angle is the smaller one. This is the 3 pi over 4 in the second quadrant. So this is the -3 root 2, 3 pi over 4. And there we go. Given the rectangular coordinate 3, -3, there are two polar representations for theta between 0 and 360. 3 root 2, 7 pi over 4, or -3 root 2, 3 pi on 4. And that is this example.